This problem, a sample of 600 grams of radioactive substance decays according to the function a of t equals, and let me write this down as I'm reading it. So a of t equals 600 e to the power of negative 0.029 t, where t is a time in years. Okay, so let's write down what this represents. T is the time in years. It's always good to know what each one of these mean. And we'll come back to that. How much of the substance will be left in the sample after 40 years? Round to the nearest whole gram. Okay, a sample of 600 grams of radioactive substance decays according to the function. A is equal to that. Okay, decays according to the function. So this tells us how many grams are left. So this is the represents the grams, and I'll put left, though probably the problem is just as simple as grams. Okay, where t is a time in years. How much of the substance will be left in the sample after 40 years? So they're telling us that t is equal to 40. And this is just evaluating a function. So plug 40 in for the t. So we got 600 e to the negative 0.029. I'll put a little x here for times, and then 40. You have to be careful when you're plugging this into your calculator. Okay, so I'm going to do 600 e you get by doing your second ln, your second natural log, then negative 0.029 times 40. Now notice I did the times on that, and then enter. And what do they say? Round the nearest whole gram, so that'd be 188. So that's how much is left after that period of time. I think it was grams. Sometimes when people plug this in their calculator, instead of doing a times between here, they'll close this parentheses, then they'll do a beginning parentheses, then a 40, and then a close parentheses. You do not want to do that. Whenever you're using the E, then you always want to just do a straight times. And that's why I put an X here, just to really emphasize that. Do not put any extra parentheses in when you're working with this E to a power. It goes against order operations.